Hi, I'm Serena.
And I'm Lijia.
And we're going to go through Test B, Problem 1.
So first a little bit about the problem. This is the line integral over c, which we've graphed here. And the function f of xy is equal to xy, comma x minus y. So we split the line into c1 and c2. I'm going to be doing c1, which is from 0, 0 to 2, 0. And Serena will be doing c2 from 2, 0 to 3, 2. So about the line, it's y equals 0x. So that means dy is equal to 0 dx, which means dy is 0. And x is from 0 to 2, so we write the integral like so. And after calculating the dot product, we get this. And now we have to plug in y, y for in terms of x. So dy here is 0, and y here is also 0. So after calculating that, we get 0 for the integrand, and after calculating this, we get 0. So that's 0.
So now for C2, so basically we have over here, so this is what it starts as originally after you do the dot product, and then you have y equals 2x plus 4 because that's like this line, and then when you do dy over dx, you have dy equals 2 dx. So then if you plug that in here, you have everything in terms of dx, and then you can plug in like here is x times y, which is written in terms of x, and then here this is x minus y, and then if you calculate that out, you get it's like the integral over c2 of 2x squared minus 6x plus 8 and for dx, and then it goes from 2 to 3, and then so you can calculate that out and you get 17 over 3.
Hi, next we're going to talk about Test B question 2. In this question, we have a region R bounded by 4 lines, y equals 3x, y equals x, and 2 hyperbolas. And we are tasked to apply the Jacobi theorem with this transformation over here to evaluate this integral. To apply Jacobian's theorem, we first have to find t prime. And this is equal to the matrix and then now we have to find the determinant of t prime, which is going to be these two, 1 over v minus 0 times this factor over here, which is just 0. Now to apply our transformation, the Jacobian transformation, we would have to go to a double integral of region B of the transformation times the determinant of t prime dv du. So now we're going to substitute the transformed values of x and y. So x is equal to u over v and y is equal to v. So therefore xy the integrand has a value of u. So the transformed integral would be u times the value we found over here. Next we're going to find the limits for the integral.
Okay, so as Amy said, we're going to find the limits now. So we're going to take the lines that bound R right here and we're going to convert them to the UV plane. So the first one is y equals 3x. So y is equal to v and x is equal to uv, so we plug that in. So v is equal to 3 times u over v. This is v squared equals 3u. So then I'm going to find this in terms I'm going to find this for v. So this could be v equals negative square root of 3u or square root of 3u, but since r is in the first quadrant, then v also has to be in the first quadrant for uv. So therefore this can only be v is equal to square root of 3u. Okay, so then the second line is very similar. It's y equals x. And we're just going to do the same thing. So this means that v equals u over v, and then this goes to v equals square root of u. Okay, and then we have two other lines, xy equals 3 and xy equals 1. So xy equals 3, you can plug in x and y again, so u over v times v equals 3, this just goes to u equals 3. And the other one is xy equals 1, so you plug it in again and then you get u equals to 1. So these are our limits, and it has to be in the first quadrant. So then we can draw out b. So b has to be between u equals 1 and u equals 3. So this is u equals 3 and this is u equals 1. And then it has to be also bounded by v equals square root of 3u and v equals square root of u. So therefore you would get this line here and also this line. This is v equals square root of 3u and this is v equals u. So then this is b you want to find.
I'm going to redraw that down here. So, our integral is the integral over the region B of u over v dv du. Looking at this, we can see that this is the integral as u goes from 1 to 3, as v goes from the square root of u to the square root of 3u. u over v dv du. First integrating with respect to v, u is a constant, so we can take that out. And the rest of this, 1 over v, becomes the natural log of the absolute value of v. Though v is entirely positive, so that's effectively the natural log of v. From square root 3u to square root u. Substituting this in, we get u times ln square root 3u minus ln square root u. And through log rules, this is equivalent to the natural log of square root 3u over square root u. U can't be 0, so this is fine. And square root u cancels, and we have the integral from 1 to 3 of u times the natural log of the square root of 3 du. This becomes the natural log of, we can rewrite this as 3 to the 1/2 times u squared over 2 from 1 to 3, and this becomes 1/2 of the natural log of 3 times 9 over 2 minus 1 over 2, which simplifies to 2 times the natural log of 3.
3, 2, 1, let's go. Hi, my name is Tatjana.
I'm Caroline, and we'll be doing practice test B, question number 3.
So this problem, they gave us two functions, y is equal to x squared and y is equal to 2 minus x. What we first did is set it up on the calculator, and we're able to get something that looks like this. And with it, we see what we're supposed to do and how to set up our integral. So by setting our integral, we know that it has to be from x squared to 2 minus x on the y part, and that x will go from -2 to 1. And inside our integral should be this function, 2x squared plus 3y dy dx. So when we start solving this, we start to get something that looks like this. We solve this integral right here, we get something like this. So when we start to evaluate it, we'll end up with something similar to this. And then once we get this, we put it back into the integral to get evaluated. So we would get this new integral.
So now we'll go ahead and solve this integral. So we'll start by simplifying this. Then after that, we'll start evaluating. And that's going to be from -2 to 1. Now we plug in 1 first. So that's going to be 11 over 6. And then we're going to plug in the -2 for x. And then we can plug that into our calculator and we're going to get a final answer of 279 over 10.
Thank you so much and have a good day.
Now we're going to talk about test B question 2. In this question we have a region bounded by R. Oh my god.
Okay, so